So in section 3, we're going to talk about the pathway of blood flow through the heart as well as coronary circulation. So now we kind of have a basic structure idea of the heart, and we can trace the path of that blood takes as it flows through all four chambers and both circuits, so our pulmonary and our systemic circuit. So remember, the right side of the heart is going to act as the pulmonary circuit pump, and it's going to be receiving low-level oxygenated blood. So where is it receiving this low-level oxygenated blood from? 3 different sources. So our superior vena cava, inferior vena cava, and a coronary sinus are dumping this low-level oxygenated blood into our right atria. We have our tricuspid valve separating our right atria from the right ventricle. It's going to hang loosely open. So as the blood is flowing into the right atria, it's also then going to be flowing through the tricuspid valve and into our right ventricle. Once our right ventricle contracts, it's going to close the tricuspid valve and send the blood through the pulmonary semilunar valve out to the pulmonary trunk. The pulmonary trunk is then going to form pulmonary arteries that are going to deliver this low-level oxygenated blood to our lungs so that it can pick up oxygen and release carbon dioxide. The left side is the systemic circuit pump. So once we've picked up the oxygen and dropped off the carbon dioxide, we're going to return the blood to the left side of the heart via 4 pulmonary veins. We have 2 on the right, 2 on the left. They don't have specific names, but they're going to drain and basically dump all this high-level oxygenated blood into the left atria. The mitral valve hangs loosely open, so as it comes into the left atria, it's going to flow through the mitral valve and dump into the left ventricle. Once our left ventricle contracts, it's going to close the mitral valve and open the aortic semilunar valve, which is going to send out this high-level oxygenated blood through the aorta, to the aorta, and out to our systemic circulation and tissues. So this is a nice image kind of showing you how the blood is traveling, and it's representing the blood as either oxygen-poor blood or oxygen-rich blood. Remember, we never have deoxygenated blood. We either have low or high-level oxygenation. If we had no oxygen in our blood at any point, our tissues would die. And again, this is showing you the same pathway that we kind of talked about. So oxygen-poor blood's blue, and oxygen-rich blood after it comes back from the lungs is going to be red. So although our heart pumps equal volumes of blood through both circuits, the workload is very different. So the pulmonary circuit, which again is going to be managed by our right ventricle, is a really short, low pressure route to the lungs. In contrast, our systemic circuit, which is handled by our left ventricle, has to push this blood throughout our entire body. So it's facing about 5 times more resistance. And there's a difference that reflects this in our heart's anatomy. So the left ventricle wall is about 3 times thicker than that of the right. And the right ventricle, in comparison, also has this crescent shape that kind of wraps around the left ventricle, somewhat like a hand grasping a fist. And the structural design is really there to help the heart efficiently manage 2 very different circulation demands. So we can see in the image here, here's the myocardium, this thickness right here of our left ventricle, and then we can see the thickness of our right ventricle. Again, from our heart to our lungs, it's not very far of a distance, so we don't need to contract with as great of a force from our right ventricle, but our left ventricle, we have to contract with a much greater force in order to send the blood throughout our entire body. So the other thing we need to talk about in this section is going to be our coronary circulation. So although our heart is actually filled with blood, it doesn't receive any nourishment from it because the myocardium is too thick for diffusion. So instead, the heart relies on coronary circulation, and it's really its own dedicated blood supply, and it's the shortest circulation in the body. So the coronary arteries are going to rise from the base of the aorta, and then they're going to go and encircle the heart. So we have the left coronary artery that's going to branch into the anterior interventricular artery. This is going to supply the septum in the front of both of the ventricles. Then we have the circumflex artery, which is supplying the left atria and the back of the ventricle. And we also have the right coronary artery. So the right coronary artery is going to branch as well, and it's going to branch into the right marginal artery, serving the right side of the heart, and the posterior interventricular artery, which is going to supply the back of the ventricles and kind of merge with the anterior artery, kind of near the apex of the heart. The coronary circulation can vary. So some people have a single artery for the entire heart, and natural anastomoses or junctions can provide alternate routes. Not always sufficient during a blockage though. So a complete blockage can still cause a heart attack. So venous blood from the myocardium is going to be collected by cardiac veins, and these are going to empty into the coronary sinus, which we mentioned is going to be one of our sources of low-level oxygenated blood that is draining into the right atrium. The major veins include the great, middle, and small cardiac veins, and there's also an additional anterior cardiac vein that's draining directly into the right atrium. So I don't want to overwhelm you with all the names of these different arteries on the heart. So for lecture, the specific coronary arteries, the left and the right, and what they branch into are not going to be tested. And the same thing with the different coronary veins. Other than the coronary sinus that you should recognize is bringing low-level oxygenated blood from our systemic circulation back to the right atria. However, these specific arteries and veins will likely be tested on your lab exam. So that's why I've included them in your lecture. You definitely need to know the pathway of blood through the heart and our body into the lungs. So both pulmonary circulation and systemic circulation.